Welcome to this evidence-based analysis of betaine's alleged hydration benefits. In this presentation, we will explore whether betaine truly helps you stay hydrated, or if those claims are more marketing than science. We will look at the underlying biology, review animal and human studies, and provide practical recommendations to inform your supplement decisions. Betaine appears in various supplements that promise improved hydration and heat tolerance. Today we will separate mechanism from marketing to see if the claims hold up. Our goal is to understand what betaine does at the cellular level and whether those actions translate into meaningful changes in how your body handles heat and fluid balance. There is no shortage of hype around betaine. Advertisements often claim that it improves hydration and allows you to tolerate heat better. The reality may be different. We will examine what the research actually shows and see if the hype is supported by evidence or if it outpaces the science. Betaine, also called trimethylglycine, is a compound found naturally in wheat bran, wheat germ, spinach, and beets. The average person eats about 100 to 400 milligrams per day from food. Betaine is used in performance and hydration formulas because of its roles in methylation and osmoregulation, while foods like beets and spinach provide small amounts. Supplement doses are much higher than dietary intake. Betaine has two primary biological roles. As a methyl donor, it transfers methyl groups to homocysteine, forming methionine. This supports the synthesis of compounds like creatine and carnitine, and eventually yields dimethylglycine, sarcosine, and glycine. As an osmolyte, betaine helps regulate intracellular fluid and cell volume. It can replace inorganic salts during hypertonic stress and increase the activity of transport proteins that promote cell survival. These dual roles have led to interest in betaine as a performance and hydration aid. Osmolytes like betaine help cells cope with hypertonic stress. When the environment outside a cell becomes more concentrated, water leaves the cell and inorganic salts accumulate. Betaine and other compatible solutes move into the cell to restore balance, helping to maintain cell volume and shape while protecting proteins. This mechanism preserves cellular function during dehydration, but it does not automatically translate to whole body hydration. Keeping cells happy is only one part of the hydration equation. Hydration science distinguishes between plasma volume in intracellular and extracellular fluid compartments. Plasma volume refers to fluid within blood vessels and helps maintain blood pressure and circulation. About 2/3 of body water is inside cells, while the rest is in plasma and interstitial fluid. Osmolytes help individual cells retain water, but whole body hydration depends on fluid intake, electrolyte balance, and adequate plasma volume. Marketing often conflates cellular hydration with systemic hydration, leading to exaggerated claims. Exercise in hot conditions raises your core body temperature and triggers sweating and cardiovascular strain. Some supplement ads claim that loading with betaine before exercise can blunt this rise in core temperature, maintain plasma volume, and keep you cooler. We will scrutinize those claims and look at the underlying data to see whether betaine truly affects heat tolerance in humans. In laboratory models, betaine acts like a molecular chaperone, reducing the need for heat shock proteins. Animal studies show that chronic betaine intake can lower core temperature and oxidative damage during heat stress, and improve the structure of intestinal cells under heat or hypertonic stress. These findings have inspired sports supplement marketing but remain to be confirmed in human studies. A review article from 2020 summarized the evidence and concluded that preloading with betaine might improve heat tolerance, as observed in animals, but that this remains speculative until human data demonstrates such effects. In other words, cell and animal studies provide interesting clues, but their relevance to athletes or individuals working in hot environments has yet to be proven. One human study tested a 7-day loading protocol, giving participants 50 milligrams per kilogram of body weight twice daily. The results showed no significant differences in fluid balance or plasma volume compared with the placebo. Core temperature increased by roughly 0.3 degrees Celsius in both the betaine and placebo groups. The researchers concluded that betaine did not improve markers of fluid balance or heat tolerance under passive heat exposure. Other measurements in the same study reinforced this conclusion. There were no significant differences between betaine and placebo in core or skin temperature during rest, heat exposure, or recovery. Heart rate, oxygen uptake, and metabolic heat production were similar across conditions. Although plasma betaine levels increased after supplementation, it did not influence heat responses. This highlights the gap between cellular theories and whole body outcomes. A small pilot study looked at 8 trained men who loaded with betaine for 7 days at the same dose of 50 milligrams per kilogram twice daily. They then cycled for 60 minutes at 70% of peak oxygen uptake in a hot environment. The Betaine group experienced a slightly smaller rise in core temperature and a marginally lower final core temperature, about 2/100ths of a degree Celsius difference. They also had an increased sweat rate and lower hematocrit mid-exercise. Total body water and intracellular fluid increases were close to statistically significant. However, there were no differences in perceived heat stress or thirst, and no performance gains. The tiny sample and modest differences make it hard to draw firm conclusions. Overall, the current human evidence is limited. Passive heat studies show no improvement in hydration or heat tolerance with betaine, and the one small cycling study reports only minimal differences that may not be practically meaningful. While animal and cellular research suggests potential benefits, the translation to human performance remains weak. The strength of evidence varies by category. Mechanistic studies of betaine as an osmolyte and molecular chaperone are robust. Animal data on heat stress show positive outcomes. Human heat studies are few and provide limited support. Marketing claims about betaine as a hydration solution lack substantiation and should be viewed skeptically. Betaine's osmolyte role does support cell survival during stress, but that does not mean it hydrates your entire body. Proven hydration strategies include adequate fluid intake, electrolyte replacement, cooling techniques, and gradual heat acclimation. Betaine may have other performance benefits related to strength or power, but evidence is mixed. Do not rely on betaine to prevent heat illness or as a substitute for water. For those who choose to try betaine, typical supplementation involves 2.5 grams per day, often split into 2 doses of about 1.25 grams each. Some protocols use about 15 milligrams per kilogram of body weight twice daily for 5 to 7 days as a loading phase. Betaine appears safe, but benefits seem to plateau at moderate doses. Select products with transparent ingredient lists and avoid proprietary blends that conceal amounts. Betaine may appeal to athletes training in hot and humid conditions who are looking for small edges after they have addressed all basic needs. Advanced lifters who already have their creatine, protein intake, sleep, and hydration strategies under control might experiment with betaine. People interested in experimental supplements and who maintain realistic expectations could also consider it. Beginners and those focusing on foundational elements such as consistent training, balanced nutrition, creatine supplementation, and good sleep are unlikely to benefit from betaine. Anyone expecting major hydration benefits will be disappointed because human data do not support such claims. Athletes on a budget should invest in proven supplements first rather than diverting funds to a compound with mixed evidence. Studies to date suggest that betaine is safe at doses between 2 and 5 grams per day. Rarely, some people experience mild gastrointestinal upset, especially at higher intakes. Betaine is not a replacement for fluids, electrolytes, or heat acclimation. If you have existing health conditions or take medication, consult a healthcare professional before adding betaine to your supplement regimen. There are several myths about betaine and hydration. One myth claims that betaine alone can keep you hydrated during intense exercise or in the heat. In reality, it supports cell hydration but does not replace proper fluid and electrolyte intake. Another myth suggests that betaine significantly lowers core temperature during exercise. Human studies show little to no meaningful change. The facts are that betaine's benefits in hydration are minimal and currently unsupported by strong human data. When categorizing the evidence, mechanistic data supported by cell and animal studies rank highest, followed by limited human data with mixed and preliminary findings. Marketing claims that suggest betaine is a powerful hydration aid fall into a tier that is not substantiated by research. Recognizing these tiers helps you make informed decisions about which claims to trust. Betaine is a real osmolyte and methyl donor that helps cells cope with stress. Animal studies suggest it may reduce heat and oxidative stress, but human data are sparse. Passive heat and cycling trials show little to no improvement in hydration or heat tolerance. For maintaining hydration and coping with heat, stick to proven practices such as drinking enough water, replenishing electrolytes, and acclimating to hot conditions. Betaine is optional for niche experimentation rather than a hydration solution. To summarize, betaine's osmolyte and methyl donor roles are biologically real, but whole body hydration depends on fluid intake, electrolyte balance, and heat acclimation. Current human research does not support betaine as a hydration aid. If you choose to use betaine, treat it as a niche performance experiment and ensure you have covered the basics first. In closing, betaine may support cells under stress, but it is not a magic trick for hydration. Rely on proven strategies such as drinking sufficient fluids, using electrolytes, and acclimating gradually to heat. Invest in supplements with robust evidence and remember that proper training, nutrition, and recovery remain the foundations of performance.